Hey guys, welcome back. In this lesson, I'm going to show you how to graph these functions without using a calculator. So first thing that we need to do is learn how to read exponential functions, how to change radicals into exponents, and so on. So how to read and evaluate exponents without a calculator. Right now we have the square root of 4. Everyone knows the square root of 4 is 2. But what we have to do in order to be successful in this lesson is that we have to put this 2 that's here and the 1 that's here. Then what we're going to do is we're going to rewrite this as 4 to the first power over the outside number. So I say this as denominator. The person who's on the outside, we don't want them in our life. They're like dominators. So we don't want those people in our life. So they're outside. So the outside person is the denominator. The inside person is the numerator. The way that we read this is we say, what number, okay, let me use my highlighter. What number do I multiply twice to give me a 4? What number, that's exactly the same number, do I multiply twice to give me a 4? So we say that number is 2. Then we do 2 to the first power, and that's 2. So let's do this. Here we go. What number do we multiply twice to give me 9? 3. Then we raise that to the third power. 3 times 3 is 9 times 3 is 27. Next example. What number do we multiply 5 times to give me 32? 2. 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32. Then we raise that to the second power, and that makes 4. You guys should pause the video and try these problems by yourself before I do them. Okay, so what number do I multiply twice to give me 16? 4. Then we're going to bring the 3 here. This is 4 times 4 times 4, which is 64. What number do I multiply 3 times to give me 27? 3. Then we bring it to the first power and we get 3. What number do I multiply 3 times to give me 8? 2. 2 to the fifth power is 32. This one's a little tricky. This one is basically imaginary, or it doesn't exist, or no value. Why? What number do you multiply twice to give you a negative 4? Nothing. Don't say negative 2, because negative 2 times negative 2 is a positive 4. So that doesn't work. Let's do this one, and then I'm going to go back and talk about this. What number do I multiply 3 times to give me a negative 8? Negative 2 times negative 2 times negative 2 is negative 8, so that works. And then negative 2 squared is a positive 4. So everyone, you can't have an even number here if this is negative, because there's no amount of times that an even amount of terms can give you a negative. But it does work for odds, because a negative times a negative times a negative is a negative. Okay, or you can say 5 times negative, 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 negative. So that will also give you an odd. But if this is even, you can't have an even number in here. So make sure you understand that, because you can't graph this graph without knowing that. How do we change from radical to exponential form? Well, the denominator goes on the outside. The numerator goes on the inside. Denominators outside, numerators inside, and vice versa. The denominator is the person on the outside, therefore the outside person is the denominator. The inside person is the numerator. So that's how we exchange it. How do we do this problem? Well, what is the cube root of 8x to the 6th? What I do is I wrap 8x to the 6th as one term, and I raise that to the first power. And then I go back and I rewrite it in exponential form. So numerator, denominator, okay? And then because this is a monomial, and that's the only reason you're allowed to do this, you can split them up. 8 to the third, x to the 6 to the third. We know how to do this. What number do we multiply 3 times to give me 8? 2. 2 to the first power is 1. So this here, power to a power, do you guys remember from algebra? You just multiply. 6 times 1 divided by 3 is 2. So this is your final answer. So with that being said, let's figure out how to do this. I wrote here, given the following functions, x to the 3/2, x to the 1/3, and this greatest integer function, make a rough sketch of the functions by creating a table of values. For the function g of x, use values that are perfect squares. That makes sense, right? For h of x, use values that are perfect cubes. That makes sense. And for k of x, we're going to use decimals and fractions. But let's start here because this one is very simple. What are some of our perfect cubes? Well, let's do 0. Always start with 0. What about 1? Is 1 a perfect cube? Sure. 1 times 1 times 1 is 1. What about 2? No. 3, 4, 5, 6, 7, 8. What's my next one? 27. How are you getting these so fast? Because I'm saying 0 to the third is 0, 1 to the third is 1, 2 to the third is 8, and so on. You can also go backwards because this is an odd number, so we can have some negatives. So we're going to go -1. Why? Because what is -1 to the third? -1. What is -8 to the third? -2, right? So I should have put -8 here. Okay, so this answer is -2, -1, 0, 1, 2, 3, 4. Now, I want you to think for a second. This is going to go really far out on the x-axis if we go to 27 and 64. So this is a little bit challenging to graph past x equals 8. So let me just see what I have here. Nope. So this is x to the third, okay? And we said 0, 0, and we said 1, 1, we said 8, 2, we said 27, 3, and so on. This function is going to look like this, but I actually zoomed in on it for you guys. So in this scale, we got from 0 to 20. Here we did from 0 to 10, and you get a better picture. So this is what this graph looks like. I'm going to graph it pretending that I didn't see this. So what I would do here is I would say 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 8, 2. And this part is going to look like this. -1, -1, -8, -2. This part is going to look like this, okay? So, with that being said, now you guys can see this picture better. Okay, great. So that's how you do that one. How do we do this person here? This person here is a little bit tricky because there's a even number there. You can't have negatives, so we're restricting our domain. 0, 1, 4, 9, 16, and so on. So do you remember how to read this? We are going to say 0 to the 3/2 is 0, because the way that you read is what number do you multiply twice to give you 0? 0, because it's 0 times 0 to the third power is 0. What about 1? Well, 1 will always be 1. What about 4? How do we read this? What number do I multiply twice to give me 4? 2. 2 to the third is 8. What about this number here, 9? What number do I multiply twice to give me 9? 3. 3 to the third is 27. I'm not going to do the next one because it's going to be large. It'll be 64. So we go 0, 1, 4, 9, 16. Okay. 0, 0, 1, 1, 2, 3, 4. And we said 4 was 8. So 1, 2, 3, 4, 5, 6, 7, 8. And it should look like this. And I also was able to use decimals for this. And as you can see, it looks like a beautiful increasing function. Okay? That's because the power is really, think about it for a second. What does 3 halves mean? 1.5. So it's not quite a straight line because it's not x to the first. So it moves like that. And our final graph is going to be our greatest integer function. And what happens in this case is every time you put a number, it's going to round down to the nearest integer. So this is called the greatest integer. So when you put a 0, you get 0. When you put 0.1, it rounds down. When you put 0.2, it rounds down. It rounds down. Even at 0.999, it rounds down. At 1, it rounds to the nearest integer. So this means the greatest integer at this number or below. Okay, so 1.4 would be 1. 1.8 would be 1. It rounds down. 2 would be 2. 2.01 would be, and so on. So if you think about it, 0 is 0, 0.1 is 0, 0.2 is 0, 0.3 is 0, all the way till you get to 1. 1 is 1. 1.1 is 1, 1.5 is 1, 1.6 is 1, and it looks like this stairs. We have the negative side here, and you have negative 0.1. Think about where negative 0.1 rounds down to negative 1, right? Think about negatives. When you round down, they're going smaller. So negative 1.99 rounds down to 2. Negative 1.99 is here, actually. So that rounds down to 2, and so on. So this is what this graph looks like. You should be able to identify it. Okay, so this is the greatest integer, sometimes called like a step. And we have open circles here because at 1, it jumps up to here. So it gets very, very close to 1, but never, right? So 1, let's say, in this case, 1.99999 still isn't 2, okay? So it drops still down to 1. Okay, so that's how you graph those. What is the remaining questions? So we made those sketches. Do the functions appear to be continuous? That means, can I draw the picture without picking up my pen? I think for 2 of them we could, so let's see. Sure. I never ever have to pick up my pen, so that's continuous. I never ever have to pick up my pen. That's continuous. But here, in order to go from here to here, I have to pick up my pen. So this is not continuous. To go from here to here, you can't without picking up your pen. There's a space between the graphs, so it's not continuous. Okay. Next one. What is the domain of each function? Which functions, if any, are continuous? I already said that. Okay, so we don't have to repeat that. But the domain for the 1/3, I can pick any numbers and I'll get an answer. Take a look at this. I can pick any numbers, any x, and I get it. What is the range, guys? The range, believe it or not, you're going to get every single y. It's going to take a long time to get to the y, but you will, okay? You will get all of these y's. Let me see. See, it keeps. So the domain for x to the 1/3 is all real numbers, and the range is all real numbers. For x to the 3/2, my domain is 0 to infinity, right? Because I keep going this way. And actually my range is 0 to infinity, because I go here and I go up. Okay? This is very interesting. My domain, can I put any number in there? Absolutely. Every single number that you put, every x value that you put, gives you a y value. So it's from negative infinity to infinity. What is my range? Are you getting all your y's? Well, am I getting 0.5, 0.6, 0.7, 0.8? I'm not getting these y's. Look at my y's. I get 1, I get 2, I get 3. I don't get 2.5. I don't get 2.7. I don't get 1.4. So my range is all integers. Not all real numbers, all integers. I'm getting whole numbers. Okay? And negatives, that's what makes it integers. But I'm getting all nice whole numbers, all integers. I don't get negative 1.3, so that's my range. Okay, let's go back here. We took care of domain, we took care of range. We're talking about which functions are even, odd, or neither. And then we're going to talk about increasing, decreasing, okay? Concaved up, concave down. So let's talk about even and odd. First, let me go to my, what do you guys think? This here reflects with the origin. So x to the 1/3 is going to be odd, right? This needs to be symmetrical with the y-axis, but it's not. Okay, so this is neither. And the greatest integer function, wherever that went, pardon me, is, what do you guys think? F of negative x. What does this do? This will actually be odd. Okay? So this will be an odd function. And then we have concaved up, concave down only for the first two graphs. So let me go here. This is actually increasing from 0 to infinity, right? It's increasing. What else? It's concaved up from 0 to infinity, right? It's a nice smiley face. Because this is a closed interval, we have the lowest point being 0, 0. So this is our minimum. Every closed interval, meaning the domain is restricted, will have a max or a min. Okay, so that takes care of that one. And then let me take a look at this. This is increasing all the way through. This is increasing all the way through, right? All my slopes are positive, except for at 0. I'm going to show you something here. My slope here, it's still increasing, but I wanted to tell you that my slope here, when we do derivatives, you're going to see that this is a vertical, it's undefined here. So it's like a vertical, it's not an asymptote, but a vertical line. So this is increasing all the way through, okay? And then this is going to be concaved down because it's a sad face, and this is going to be concaved up because it's a happy face. So because it switches concavity, we have a point of inflection at 0, 0. Okay, so that takes care of that one. Our end behaviors, well, in both cases, let's see, as x approaches positive infinity, y believe it or not, it's going to take a long time to get up there, but it's going to increase. As x approaches negative infinity, believe it or not, it's going towards negative infinity. Also, how do we know that? It's odd functions. Okay, so this one is as x approaches positive infinity, so does y. Remember, we don't know what happens on the other side of this because they're not real numbers. So this doesn't work. Okay, and I only asked you to do it for this function and this function, not for this function. And I said for the last problem here, I said for the function k of x, discuss what happens to the y value as x gets closer to the value 2 from the left and from the right. Okay, so let's take a look at our function, our step function. What happens as x approaches 2? So remember, I'm going to delete this or erase it. I'm just going to leave this here. Okay. When x starts getting closer and closer to 2, what's my answer? So what you want to do is, let me get rid of this also. What you want to do is you want to split the page up. Let me do that. Okay, this is left, this is right. That's right. And when x approaches 2 from the left side, my answer is 1. So as x approaches 2 from the left side, I should actually just show you the notation. The limit as x approaches 2 from the left side of this function is going to be 1, right? When you're going towards 2, what's my answer? The limit as x approaches 2 from the right side, so when you're going towards 2 from the right side, what's my answer? 2. And we'll discuss that more later on. So this is how we do this lesson. Have a great